All right. Yeah.
What's new in your world, Animal?
No, I keep enjoying my tiny loudspeakers, the LS35. What I decided to do, I have more projects than time to do them. I think that is a fairly common situation.
Yes.
But like 2 years ago, a friend gave me an amplifier that is quite interesting. I don't know if I already mentioned that. It's one of the well-regarded tube amplifiers from Sansui, the AU111.
Wow.
The first one with black front. And it was on a basement. It was full of bugs. So when I got the amplifier, I disassembled it, I cleaned it, and I purchased a set of capacitors for the power supply to recap them. And that was all for 2 years. So I have proposed myself to do this in the short time. So I have it now on my bench and trying to decide what to do, how much I will go on the rebuilding or not. So
fun.
Yeah.
So if it's a black face, does that mean it's from the 1980s?
No, it's 1967, 68.
Wow.
Okay.
It's the, I will tell you something. It goes for $5,000 on eBay.
Oh.
It has huge transformers made by a guy called Hashimoto that says that is the very, very well regarded. It's a collector thing. All the caps are oil, paper and oil. And I don't believe in too many of these things, let me tell you. But anyway, I saw the schematics, and for me, it looks a little bit like the Macintosh circuit. The output tubes, 6L6, are coupled by the anode and the cathode. So the output transformer has dual windings for the anode and the cathode. And as far as I remember, that was something developed by Macintosh. It's really, I will show you next time. It's really heavy, so heavy that has casters instead. It's a beast. So I hope that next time I can show you part of the rebuilding process.
Yeah.
Do you have Annabelle, do you have an opinion about what characteristics of loudspeakers lend themselves best to a push-pull tube amp like that? I'm assuming it has somewhere in the range of 40 watts or something like that. Is that true? Or
yeah, this is 40 watts per channel amplifier. Yeah.
Have you found a kind of just a general range, a type of speaker that just works best with that?
No, the only thing that I have for sure is that the output impedance of the tube amplifiers is something that you should take into account. So when you made a loudspeaker for a tube amplifier and you don't want that the frequency response is modulated by the impedance of the speaker, so I think that the impedance of the speaker should be compensated to be fairly flat. Yeah.
So if you were designing a crossover for that, you would probably use like impedance compensation on each driver type of thing?
Yes, first impedance compensation for the driver, so you design the passive crossover, but then if you plot the total impedance of the crossover, maybe you can add also a network at the input to make it more resistive. This is something that Kev did in the 90s or 80s to make a load that could be more easily driven by the amplifier.
Would you just use, you would add impedance, would you do that at different, whatever point you could, like by using maybe a coil with a smaller diameter wire, or, I mean, you wouldn't just
No,
put a, you wouldn't put a
usually,
resistor in there.
usually you end with the Sobel network, RC
Uh-huh.
to ground, or
Yeah,
suppose my quad electrostatics, they have at the input uh, uh, 80 microfarad caps in parallel with, I think that is 3-ohm-3 resistor and all this RC network is in series with the whole speaker, and the only purpose of this is to compensate the impedance. So it's to make it the load to the amplifiers not to be so heavy.
yeah. So is that, the one you just described is like a Zobel?
Yes.
Okay.
Yeah.
I have some of the, in my open baffles, I've been using some Bozak drivers, which were originally designed around tube amps, because they were originally, Rudy Bozak came up with that design in the 50s, I think. So yeah, I had a hi-fi set, I still have it, that came from my ex-wife's grandfather from I think it's 1960, and it's a Mac 240, and it came with the Bozak speakers. Yeah, I mean, I've had variable results when I've tried that Mac amp with certain speakers I have. I just kind of go, it really doesn't do anything for me, you know, on some of them. So I've never really known why, though. That's all.
Yeah.
Sometimes our expectation from equipment change over time. Like it happens to me more frequently with movies. Movies that I saw many years ago, I say, "Oh, that was fantastic." When I saw again, not so much. And with audio equipment, sometimes happens the same. If you listen to equipment when you were a teenager or something that was, whoa,
Yeah.
that blew me away, and when I have the opportunity to listen to them again, probably our taste has changed.
Yeah, and the compact disc and digital in general has really gotten us used to hearing a lot of bass, deep bass, you know, which we just didn't have on records very much.
Yeah.
Yeah.
Hey.
Yeah.
Cool. Well, I put together a couple slides to talk about crossovers if anybody wants to hear.
Sure.
I'll launch into that. Let's see here. See if this works. All right. So do you see Howard's living room?
Or something like that. Yeah, right. Whatever that room is.
Yeah, there you go.
Okay.
Well, so
yeah.
I worked with Howard to make a digital crossover for his bass boxes that he. So this shows his beautiful towers on top of his bass boxes that have two 10-inch. What are these? These are Dayton.
Yes, Dayton RS 270, and in this case P for paper. And they also have an aluminum version.
Yeah, so really nice 10-inch woofers in what, 2 cubic feet or 2.5?
No, it was less, man. It was I think we ended up thinking there was about 0.7 or 0.75 per driver.
Per driver. Okay, yeah.
After allowing for driver displacement and bracing and stuff. Yeah. So it's,
Yeah, so they were there. If you happen to be there, you had a chance to hear them at the club. And yeah, we thought, boy, they sounded really great. And so I thought, well, I could describe how I did some compensation for them. So This is WinISD, so I just plugged in the woofer specifications off the web page. And so there you go. So with 0.7 cubic feet, that's actually really well suited to this driver, which is very small for a 10-inch woofer. It's great. You get the Q of 0.702 or whatever you want, something around there, typically. And so the idea was, so you get this response, rolls off at the high end because of the inductance of the driver, and then at the low end because of the tuning in the box there. So it's tuned to 62 Hertz for the 3 dB down point. And so, but Howard was hoping to use this to fill in between, as a subwoofers. So his other system actually cut off about 60 Hertz, the upper drivers in this. So these drivers here actually played nicely down to 60 Hertz. So the goal of this was to have this to start at 60 and go below that. So so what we did is, so I just discovered I had in WinISD, you can actually do the Linkwitz transform. There's a under here. So if you're at the screen here where your little project, this is each little design, and one of the tabs is EQ filter. And you click on that and you get to see this box, and then you can say add a filter type Linkwitz transform. And so here I said, oh, let's do, it fills these in. This is what your driver currently has. And then you want to compensate it down to 35 Hertz, I think is what we did, or thereabouts. And then it will just create the appropriate filter. So here's the Linkwitz filter that would make it play down to 35 Hertz. And so then when you apply that, you get this response. So there it is, playing nicely down to 35 Hertz. And so this is the theoretical model, of course, in WinISD. So then if you want to do that in your system, well, you need to actually build the filter. So the folks at Mini DSP have a spreadsheet you can download that will do these things. It has a variety of filters that you can create with this spreadsheet, including a digital version of the RIAA curve. But so the Linkwitz transform is the tab called LT. And it's very simple. You put in the 4 numbers here, the initial roll-off frequency and damping ratio, and then the roll-off frequency and damping that you want. And then it builds the pole zero canceling filter that then produces the same shape. So you'll see the shape of the filter looks just like the one in WinISD. But what this does is it gives you the filter coefficients that you can. So you need this list of numbers here to you type them. If you put them in a little text document, it makes it kind of handy. Then you can cut and paste these numbers. This is the format that a Mini DSP wants to see. So if you go over and open your Mini DSP, it looks like this. So you have a couple of buttons here. This shows the inputs. Thing to note, this filter has some gain to it, 12 or 10 or 12 dB. So to make sure the Mini DSP doesn't clip, I set the input gain to minus 12 dB. So that means any signal that went in the low frequency would get boosted 12 and you'd come back out at 0 dB. So you wouldn't run into any trouble. Then you go click on this button here that says outputs. This just shows how the 4 inputs get routed to the outputs. So there's 2 inputs, and so we're sending input 1 and 2 to the first 2 outputs, and input 2 to the other 2 outputs. And so then when you click outputs, it takes you here, and this is describing filtering and gains for each of the 4 outputs. So we click on the Parametric EQ button here, PEQ. And it opens up this little screen. And you can make any kind of filter you like in here. There's 10 of them for each output channel. So you pick advanced, and then you can paste in the numbers. So you would just, yeah, cut and paste those numbers from the spreadsheet. And lo and behold, it shows you what the response is going to be of that filter. And it looks the same as the other pictures, so that you know you're on the right track. And then the other thing I did, since we didn't want bass above 60 hertz, because the other speakers, so effectively, you know, the crossover portion of this is the equalization to give us a nice low response. But then we went ahead and put in this 57 hertz 12 dB per octave to match the 12 dB per octave roll off of the natural woofers, a natural roll off of the woofers from his other system. So that would come here and roll off. So here's, and that was basically all it was required. I don't know if that makes sense. Anybody have any questions? Shout out. But so that was what we did. It sounded really nice. It made really good use of those two 10-inch woofers. Made nice, strong, deep bass, and very, very clear sounding.
And very, very rarely from any distance at all can you really even see cone movement, even when you're playing very low frequencies.
Yeah.
I mean,
So
you get up close to it, put a tone generator on and play 25 hertz, and you know you can see it move when you're up close. But and it does cut off. Well, it cuts off at about, the whole combination of everything cuts off at about 25 hertz.
yeah.
And it's probably down several dB from 30 hertz, I'd say.
Yeah.
At 25, but it's there. And if the filter was a little different, it might play even a little lower.
Sure.
I think the resonant frequency of the woofers, they're in a small box, but the resonant free air frequency of those woofers is around 22 hertz or something like that.
Yep.
Yep.
So I'll show
but
another quick example here, what I've done with this method to go the other direction. So if you're, you know, say I was trying to cross over, I was using this as a mid-range. And so I actually went and figured out, okay, this is the response with WinISD, and got the Q and the cutoff frequency. And what you can do is use the Linkwitz transform to form a high pass filter, to give you really a perfect high pass filter that cancels out, you know, the natural response and replaces it with a higher frequency response instead of boosting. So in this case, I was driving this driver. So this is the driver with a typical amplifier where you've got a QMS and a QES. So damping provided by a low impedance amplifier produces the QES. Well, I wanted to run this with a current drive amplifier, which is effectively like, you know, setting the QAS very high. So if you do that, you see, oh, okay, well now this driver would really have a ring to it. So there you are. This is what the response would look like with a current drive amplifier. So then if you came in with a Linkwitz transform for this, you could say, oh, I want to cut this off at 150 hertz because I had a 12-inch woofer in this system as well. So I was going to have that one 12-inch play up to 150. So what this would produce is effectively a nice response now that would roll off right at 150 hertz. So now this is what the response with that Linkwitz transform looks like. And so you just get the perfect response. It's eliminated that peaking response completely. And so it allows you to then use this driver with this current the transconductance amplifier, and it just works beautifully. If you were to just go ahead and put in a just a 150 hertz high pass filter and not use the Linkwitz transform, this is the response you would get. Because it had that peak in here, you get this 2 different roll-off points and a kind of a mess. So this would be a disaster to try and, link up with 150 hertz response from your woofer. So that's kind of the, yeah, so it allows you to just completely eliminate the original response. And then here it is, if you wanted to, because ultimately what I did was I wanted a 4th order, so I could have a 4th order Linkwitz crossover. So you just add in a second 150 hertz Butterworth section in series, and now you get the 4th order. So you really get the perfect 4th order roll off for that system at this point. So yeah, cascaded 2nd order high pass to produce the 4th order high pass. So its roll off is going to be 6 dB at 150 hertz now. But anyway, that was all I wanted to talk about. So I'll have
Quick question
you-
for you, Dana.
yes.
I saw that you didn't use any subsonic filter. Don't you have any concern that the woofers can run into an over excursion or something like that?
Well, we didn't have any trouble. Of course, we were playing from digital sources. If you were going to play with a turntable, you'd want to go and put something in there, 20, 25 hertz or something. But with,
With digital sources, no,
digital
no
sources,
risk.
you don't run into this trouble. No, people, yeah, I can stomp around the CD player and I don't have any trouble. So yeah.
Hey, Dana, what about phase and time alignment? Because you can also do that with the mini DSP, but how do you measure that?
How do you measure the phase? Well, I mean, short of an oscilloscope or using the time alignment you could do with clicks, impulse response, look at that. And so ultimately that's probably what you want to do is, put the click through the different, and have it come out the different drivers and then go through and line it up with, you could see it, with a measurement microphone, you'd be able to, play the one driver, play the other driver, and then overlap them and fine tune it for particular, because you're going to ultimately be fine tuning it for a particular vertical axis. But yeah, that can be done for sure. Yeah.
Is it audible? I guess that's the question.
Oh, well, so I guess what would happen is the simplest thing to do is a frequency sweep. And if you're aligned properly, you'll have a flat response through the crossover region. As soon as you introduce some phase error, you will either get a peak or a dip, because you'll cause a cancellation or a sum or addition, which will produce a loop. So the more time misalignment you have, the larger the peak or dip. So so oftentimes people will invert one of the drivers and that will produce a dip, right? And if you're perfectly aligned, as you adjusted that delay, you get a deeper and deeper dip. So you would adjust it to get the deepest dip you could get when one is out of phase. And then presumably if your crossover is designed to pair properly, when you put the correct phase on the driver, it should be flat. So that's typically what I do. Yeah, it's easy to do. But yeah, and you can play with that in any of the design software. You can go in there like XSim, you can go in and flip the phase of one driver, and then you can look at, all of a sudden you'll have these cutouts, these notches at where the crossover frequencies are, the notches will suddenly appear.
Well, so I noticed, yeah, because it was on the mini DSP, you can adjust the delay.
Oh yeah, you could just get in there and just change it with this. Yeah, it's really nice. Yeah. I don't think we got into that fine tuning with Howard's. We probably, we got it done. We listened to it. And I think we were out of time. But that would be something he could definitely play with. He still has all the stuff. Yeah.
Hey Dana, do you what's the sound card you use for all this simulation? And like the computer needs to have a sound card so you can do the crossover, right?
Yeah, to do the measurements with a microphone, you'll want a sound card. I use where did it go? Here it is. It's down here at my feet. But so I've used this one for years, the Sound Blaster Sbx. So it's nice because it's separate. It just plugs in with USB. I can plug it into my laptop. I can plug it into my desktop, take it wherever I want. It's a handy device. It's got headphone, microphone, and it also will do turntable. So you can plug a turntable in here and it will do the RIAA equalization in here as well. So
wow.
It's just kind of, and it has optical inputs and output as well as the RCAs. So very versatile. Not perfect, but very, very good. Good enough for doing the kind of things I do. And then if you combine with that, you know, this is a 10-to-1 divider box. So it's got two 10-to-1 resistive dividers. So if this has a range of 1 volt, I can now measure 10 volts and look at actual amplifier outputs and things. So
but Dana, the crossover itself, I mean, the sound card for this crossover is the mini DSP itself.
Yes, correct. Yeah. So when you're actually running
when you're running it, it's A to D and D to A.
Yes. Right? Yep. So it does. It will do that. You can do analog into it or digital. I typically I have in my bigger speakers, I have a mini DSP in each speaker and I run an optical cable to it, to each one. So I have optical speaker cables. I'm a little weird.
So, what did you do for Howard's system? You know, how is his connected?
Analog from a little analog mixer.
Analog mixer.
Yeah.
To the mini DSP and then out from the mini DSP. Okay, A to D, D to A.
And is that a box or is it a kind of little computer plug-in? You know, like it goes into a port. This mini DSP.
It's a box similar in size. I don't think Howard's at home. It's a box similar. It's similar in size to this. There, you know, so it has a power supply and then it has analog inputs and 4 analog outputs, optical input. So it's very similar. But yeah, it's a. Well, you wait. Well, you have one, Siddhartha.
Yeah, I have the digital version. Yeah, I was just wondering if it's like a different thing you were using.
Yeah. So it's like the thing you have. Yep.
And then Dana, have you had any experience? I'm curious as to your choice of the software, because there's this. I've been reading about digital signal processors, and this name keeps popping up. DRC is Accurate, which does. It's not spelled as ACCU, it's ACCOURATE.
Yeah, I'm familiar with that. It's a digital room correction software. Yep.
Digital room correction software plus crossover plus a speaker corrector. What's your experience with that actually? With is it too much for your purposes, or have you tried it?
I've read about it. I was already into the mini DSP world, so I think, you know, I think their hardware is $1,200, $1,500. I can't remember. It was significantly more money.
But
yeah.
they have hardware. You're saying like an external box for crossovers and things, or a sound card.
You know, I assume they're targeted at somebody's hardware. I mean, so they generate filters. I'd have to go back and look again. It's been a year or two. I delved into room digital DRC software a couple of years ago when we were playing with it and found, you know, several freeware versions that seemed to work fine. And so I have those. Maybe I'll talk about those again sometime. But yeah, I mean that's the commercial stuff's much, it's very simple to use, and the freeware stuff, it requires a little bit of fiddling.
Mm-hmm.
So if you're not a software engineer, you might not appreciate it.
Uh-huh. By the way, Dana, have you started using the mini DSP Dirac version 3?
No, yeah, I never did buy the Dirac because I could generate the filters using this other software I had for free.
Uh-huh.
But yeah, well, and you have to dedicate the box to it. You have to load the Dirac firmware into the box, and then it won't do the other functions.
Yeah.
So yeah, I'm thinking about buying yet another mini DSP because you can't have too many.
And then what's your experience with is it a different function, the REW, Room EQ Wizard? Is that a thing you've used?
So that will also create, yeah, that works nicely. It makes a certain type of filter, and I've used it a little bit, and that's probably the easiest one to use that's free.
Uh-huh.
It has a nice room simulator as well, so that's kind of fun to play with speaker placement. Yeah.
Well, it's all really interesting, but like you're very fluid with the whole. You obviously really used it, but it looks a little complicated from the outside. Like for a newbie. Like all the it's quite, and you explained it very well.
Well, I spent several years getting a master's in control system design, so for me it looks a little familiar. For anybody else, you are very much correct in feeling a little overwhelmed, but luckily, if you have all the things that once you have that spreadsheet and the I think pretty much anybody in a half an hour could go through the process and be successful, since it's really just typing a couple numbers and cut and paste. But yeah, kind of to fully understand it, there's a lot of theory, but you don't really need it to really just use it. I'd say a lot of people probably use this successfully without. But yeah, you want to keep the things in mind. It's it's adding gain to the system, and so you don't want to go nuts and try and make a 5-inch driver do 20 hertz bass and things like that. But
so Dana, how do you read the manuals, or how do you know what to click? And like, I know it's a rudimentary question, but like how do you generate, like, the software piece itself? Is it just you playing around and you figure it out, or do you actually read a manual, or how do you figure out what to do?
So I read on the mini DSP site, and so they have some tutorials there, how to use their device in the different modes, but there's probably not and if you could Google Linkwitz transform, and it kind of explains what it does in terms of canceling one system's response and replacing it with another response. But I mean, it looks a little magical, but yeah, and to actually use the software, the WinISD, I just got in there and started clicking. I imagine there's probably some YouTube tutorials out there. Yeah,
I think I have some comment about that, Siddhartha. One kind of equivalent example, it might not be quite as technically as involved, is like Dana originally walked me through the setup of the measurement microphone using Artist software, hooking up that Sound Blaster. I got one of those Sound Blasters, hooking that up, and it's all a bunch of little details. And then there's inside of Arta, which is the measurement software, which you can use in demo mode for free. There's a lot of setup stuff where you have to click the right boxes and make sure. And every so often I've gotten derailed with that, needed a little help. But it's kind of like it's kind of like it's kind of like if you said, if you had never used a PC before, and someone set that one down in front of you, it would just be Greek, you know. But after a period of time, after you approach it one time and another time and another time, the things become, I don't know, I don't think intuitive is really the right word, but it becomes habit. It's muscle memory. It's,
Yeah.
you know, and so the less of those things that you're having to stop and go, now what the hell is this about? The anxiety level goes way down because you go, oh, I know what to do there, and you do that, and then you can move on to the next problem. And so whether you're learning off of a YouTube tutorial or you're reading the text in the help manual or whatever like that, you can't expect to just pick it up and work with it. But after a period of time, if you do work with it, then a bunch of it just becomes fairly natural. And Dana could maybe make a comparison with the mini DSP stuff versus the measurement software stuff and how equivalent they might be or might not be. I mean, Dana did that one crossover for me with the mini DSP, and I got his mini DSP at my house, still running that same system. So I haven't really gotten in there and worked with it. But so it still seems like, it's like what you're saying. It's like, oh, I have the same apprehension about that, you know, at this point. But if I start working with it myself, then I think a lot of that will go away.
Right.
So, you know, and neither you nor I have a very deep technical background.
Yeah.
But the more we play with the stuff, then the more we learn about it.
And then I had another question for any of you, including Dana. You know, obviously these digital crossovers are extremely flexible, and there's a lot of things you can play with on the computer. What's the comparison to sound wise or otherwise to an analog crossover, which is, you know, not non-digital, you know, it's in a box, or it's, you know, you've designed, like I think Dave has designed, I think, an analog crossover often for his speakers. Why use digital or analog? I mean, what are the advantages or disadvantages, if any?
Well,
there are books about this, and you want an answer.
It's easy to, especially if you're only building a speaker for yourself, it's very easy to do it with a digital crossover and get very good results. Because you can very quickly change it, measure it, change it, measure it, calculate what you need, like I did. So here we calculated what we needed. If I would try to build that circuit I just showed, if I tried to build a circuit to do what that Linkwitz transform does, I couldn't do that with a passive crossover at the speaker. You could probably do it with a passive crossover at the preamplifier, but it's going to be very difficult. A lot of calculations, and you could get there, but in the end, I think it'll be more money, and then potentially difficult to change. You know, you go buy the parts for that one thing, and then, oh, it didn't quite make it, I need to add another capacitor here and there. But
along those lines, Dana, I had a question.
Yeah, but yeah, you're stuck with more amplifiers is the downside, of course. But yeah,
I noticed on that Linkwitz transform, many of those components had the coefficients had many significant figures. Are all of those probably required? How far out do the computer doesn't matter, right? But if you were to try to make an analog equivalent, how close to those values would you have to be?
So the thing to understand with those coefficients is those are related to a 96,000 sample per second math. So when you're talking about doing something at 35 hertz, the change you need between a 1 and something less than 1 to do something that makes the signal move at 35 hertz is a very small fraction of 1. And so that's why it looks that way.
Okay.
I mean, you know, if you were doing this, like you're thinking, oh, but it's going to be a 3.7 millihenry choke. Well, yeah, that's, you know, plus or minus 5% is going to be plus or minus 5%. But when you go and you say, oh, I'm going to do, instead of the 1 being in the coefficient, it's 0.99999873473. But what matters there is the difference it is from 1. And so if the difference from 1 is 0.000137, well, a change of 5% of that number is significant.
Okay.
So if that makes the difference of the difference. So anyway,
Yeah.
so, but yeah, it's a cut and a paste in the computer, but yeah, to actually get it, if you were to go in there and round that off to 5 places, it could move it from 35 hertz to 150.
Sure. And I guess the consequence of that is, like, I encounter all the time doing analog crossovers. It's a lot of trial and error. Sometimes you're close, but it's not quite close enough. So
yeah. But,
sometimes 5% is good enough. Sometimes you want less than 2%.
Right. Yeah. So, but yeah, you can go in there and to really help comprehend what's going on, after you load the filter into the mini DSP, you can take your signal generator and a scope and do sweeps through there, and, you know, really kind of explore the behavior of the beast after you've configured it. Yeah.
One comment I would make along Siddhartha's line of questioning about the analog is one way to get an idea, if on a DIY level, not like buying a Behringer professional rack mount type, you know, they're not super highly thought of, but that is a brand, and you know, and you can just dial those in, whatever. But if you're actually going to build a custom filter, kind of like Dana did with the mini DSP for mine, if you go look at Siegfried Linkwitz's website, which I might still be up, I think it's still up, and you look under his the more recent of his builds, I think he shows schematics maybe without the values. I'm not sure, but anyway, it gives you an idea of how complex those analog crossovers can be, and so you get an idea of, well, if you had to build one of those, or, you know, heavens to have it, you know, good heavens, having to hire someone to build one, you'd start thinking the mini DSP was pretty nice. And the other thought I had about it is that in the base, it just seems, I can't, you know, I mean, I'm not the most discerning audiophile, but I don't hear any artifact of the digital there that's makes it sound artificial or anything like that. It's just super, the whole thing just ends up being super clean. So as far as that part of it goes, you know, purist side of it goes or something, but the Linkwitz's website, where he got pretty into multi-amping and using analog crossovers that he designed for his open baffle speakers. I mean, there's some complexity to the electronics. It wouldn't be a problem with certain of our members, you know, they wouldn't have any problem with it, but for some of us, it'd be a pretty steep climb. So, yeah.
I made the original Linkwitz. I have here my collection of Audio Amateur, the magazine, and Speaker Builder, and I think that was in the 80s that Linkwitz published his three-way system, where he used the 4-order, and what was very interesting for me, he made analog delay with all pass filters to align. So I repro that many years ago, and sound pretty good.
Oh, nice.
Yeah.
Yep.
You know, sadly, Linkwitz passed away, I think 2 years ago, but many years ago, he was selling a DVD with all the content of his website. There is no there are no there the latest design, but if someone is interested, I purchased that from him. I have it here. So.
Oh, wow.
Yes, yeah. And when he passed away, I also printed as a PDF many of the things because I think that it was very thoroughly, very interesting. My lack of English, sorry, I apologize. I cannot find the right words. I think that he was a person that has a lot of technical knowledge, but also listened to the equipment. And that's something that I really appreciate.
Yeah. Oh, yeah.
I talked to Siegfried many years ago. I visited him at his house in Corte Madera and listened to his speakers, but he told me how he did his development, which is he would put on a pair of a vinyl, of stereo microphones over his ears, okay, and a little recorder in his pocket, a little digital recorder, and he would leave the house and go to a concert in San Francisco and then come home, leaving the recorder on the entire time. And then he would play it back on his speakers to see how closely what he had recorded matched what he had heard. It was amazing. And he said, in that way, he said he was able to optimize many parameters that people don't normally think about in the speakers. I mean, the whole, especially time domain stuff, because like walking through a parking garage, and all the sounds that you hear. And that was, he did that every time. And he went to the concert. He was faithful. I mean, every SFO concert that he could go to, he went to every one and recorded the things with his little binaural microphone set up. And then he would play them back and listen to it. So he had good references all the time for his development. And so, plus his background, was in antennas and RF stuff. So he knew about propagation, etc. So he understood, the analog between the loudspeaker propagation, the acoustic propagation, and RF radiation propagation from antennas. So it was like, a good, what shall we say, a good strength to have, to have that combined approach to things. So yeah, quite a guy, very interesting, and also, very, very wonderful person. I mean, so accommodating. I mean, he just, he would loan people stuff, speakers and things. I mean, he was incredible. I'm sorry I only, got to spend that one day with him, but it was definitely worthwhile.
Wow. Yeah, well, so his website's a huge gift to the world. It's amazing. If you haven't looked at it, it's got a lot of nice content there.
It's a life's work. You look at that amount of time that he's put into that. I mean, that really was his total, I mean, and his living room was just dedicated to his pursuit of the building better loudspeakers. Pretty amazing.
Yeah.
So.
I just taking off a little bit on from what I've been hearing with the subs that Dana created the crossover for, and my latest kind of open baffle that I've built. I would just like to kind of convey that if you don't want to have really huge woofers like the 18-inch woofer I used on my previous open baffle, that below 50 hertz, I'm finding the quad 10s, it's two 10s per side in sealed cabinets. And you could probably do with half of that unless you're going to play it really loud. It fills in really nicely below 50 hertz, and most open baffle stuff, if you have 12-inch woofers or bigger, around 12-inch woofers or whatever, will go pretty nicely to 50 hertz and then rolls off pretty quickly after that. And so I guess what I'm saying is just that you can use a subwoofer setup like that, a sealed subwoofer setup. I'm not sure ported would end up sounding very good, but a sealed subwoofer, which is fairly neutral sounding, you can supplement the open baffle and kind of have a hybrid setup, and it's pretty satisfying sounding, pretty good sounding. If you have a 12 or a 15-inch woofer that's doing your low end on your open baffle, a lot of times the woofers get used for that are a higher Q and a higher sensitivity, little bit more like a pro type of speaker, which some of them sound good enough to do it. But they tend to have a resonance frequency 40 to 50 hertz. And so in the open baffle, they go down to about that pretty strong, and then they drop off pretty quickly. So the sealed woofer adds that feeling of, it adds some feeling of space and of whatever it is those real low frequencies give you, that just makes it feel big and whole. Works pretty well, but it's, yeah.
Howard, what's the difference between, and maybe others can respond, but having two 10 inches, I mean, I don't know, in terms of the technicality, but like, it would seem like having two 10 inches would have a certain efficiency versus one, like whatever, 15 inch or 18 inch, the 18-inch woofers. But like that choice of two things dividing the sort of the whatever the mass, whatever the mass of the, like the cone mass would be, is that a right line of thinking? The cone mass is more efficient when you have two 10 inches versus one larger woofer?
I think that if you're just technically looking at the amount of output you can get, it's all relative to the cone area and the excursion that's possible. And some woofers can move 5 millimeters before they start distorting a lot, and some can move 15, say, or 11 or 12 or whatever it happens to be. And the subwoofers, the modern subwoofers can move 12, and there's even some that are move up to like more than that. So that's technically that's the difference there. My sense about it, like this, the Dayton woofers that I used, I think that the amount that they can move without distortion, which is typically ends up being called X max. It has to do, the millimeters has to do with how long the voice coil is and how big the magnetic gap is, and for when the voice coil moves outside the magnetic gap, that becomes past the X max. But I'm thinking, and I haven't tried it, but I'm thinking that you might get a better sound out of the two 10s running at 6 millimeters, as long as they're staying within their X max, as you would with 110 that could run at twice that X max, even though technically they'd have the same output capability. And I think it's going to sound subtly different, That's all of that talk is all about boxed woofers. None of them, just for clarity here, because I was talking about open baffle before, that largely is a different picture, and it's a different type of driver than you end up with in the open baffle, just for that muddy clarification. So does that and there's probably a lot of other factors that enter in, and I'm sure maybe Dana might have something more to say about it. Or someone else.
Yeah, my thought was, if you have several small woofers, or if not 10-inch woofer small, but that that cone will hang together up to higher frequencies. It'll be a pure piston. It won't start bending. You start looking at 15s and 18s, and they start bending. at lower and lower frequencies. And so you avoid all of that. Potentially is probably the only difference, you know, because you go, oh, is a 15-inch woofer the same as 210s? I don't know, area wise. There's going to be some woofer there, right? That would be the same area. But the difference is, you know, the 10-inch woofers will be stiffer. Just the smaller woofers will be likely a little better behaved. But yeah, there's something about having a lot of surface area. Hey, we're now connected to Spokane and the ocean.
John, welcome. Wow.
We got Dana out at the ocean. We got John in Spokane. This is fantastic. Oh.
Anyway, hi, John.
Hey, John.
I don't know, he's got his audio on.
I don't. Yeah, we don't hear you, unfortunately, John. But
well,
oh, there you are.
Can you hear me here? Maybe I was too far away.
That might be it. You got above the squelch threshold. Now you're in.
Trying to make.
So another question, since there's a little gap in the process right now, as we, there's strong opinions about, since we're talking about subs, ported versus non-ported. I believe, Dana, you're pretty strong about not having ported subs, or was it Howard that had that opinion? I forget.
Yeah, I'm in that camp now. I'm in the sealed. I'm more strongly in the sealed camp now.
Are you getting more? What is it that you're getting that's you're not getting in the ported thing?
I could explain that. Oh, I'll give my perspective real quick. Sorry. So a port is a resonator, and so if you look at a ported speaker, there's two responses to look at. One is if the port's not active. So you'll have a speaker that then rolls off at a relatively high frequency. So it might roll off at 60 hertz, for instance, like you saw Howard's speaker there without a port in a sealed box. It's going to roll off at 60 hertz. Now you go throw a port in there and it's going to put a resonance in there that, you know, 30 hertz, 40 hertz, something like that, right? And that resonator will then fill in and it'll make it appear to have a lower response, right? But what's happening is if you put in a short, you know, say you put in a single cycle of 60 hertz into a sealed woofer, it will produce that single cycle, right? Now, if you put that 40 hertz tone in to the ported speaker, that first cycle is going to be down, whatever, the 10 dB or something, because the port hasn't had time to start ringing.
Right.
So that first cycle will just come out of the woofer, and you'll get the sealed box response of that woofer for that first cycle. If that first cycle happens to be the first part of the kick beat of a drum, what's going to happen is it'll be 10 dB down from what it should have been. Now, eventually, if it's a sustained 40 hertz note, well, the resonator will start building up energy, and suddenly it will produce that what they don't, you know, it'll produce the infinite time frequency response, which is what everything is published for these speakers. That frequency response is if you play a tone forever, that's the response you get out of that speaker. It's not the first cycle, the second cycle, the third cycle. So you just basically miss the dynamic impulse at the beginning of, especially you think about a lot of these things, the waveform of a bass drum or something, or a plucked string, it starts off big and then it attenuates, right? It goes bam, and then it comes down. And so what you end up getting is kind of a, instead of just the immediate peak, you get a rise, and then it intercepts and it may overshoot a little bit, but so it makes a sound, but it's not a high fidelity sound. It is producing the same sound every time you hit the bell. It does the same. It rings like a bell would ring. And
it's time smeared.
It's time, yeah. And so it doesn't reproduce something, it plays something. It's more of an
Right.
musical instrument than it is a reproduction.
Right.
Okay.
So that's my, having thought about this for many years, this is what arrived in my head in the shower 2 months ago.
So my question is how I'm not doubting what you're saying, but why do manufacturers and high-level speaker manufacturers, they use ports to augment the the sound of the low end?
Sure.
How come they're choosing that when you're not really getting a high fidelity sound?
Well, it's Howard's design that we did is a perfect example of that. So you look at what we did and we said, hey, we wanted to do a sealed speaker. We bought, he bought these beautiful 10-inch woofers, put them in the appropriately sized box, and they made effectively no bass. You know, they rolled off at 60 hertz. And so then you go, well, if I'm gonna make a speaker that I'm going to hook to a normal amplifier, what do I do? So you either go and you make an enormous 6 cubic foot box, and then you add a bunch of weight to the cone to lower its natural resonant frequency down to something, 30 hertz when it's in a box, which means it's going to be 15 hertz outside of the box. Now the cone's very unstable and it's difficult to keep it lined up. So it has been done. Speaker Lab's done it. They make these very heavy cones but it ends up, they're lucky to get down to, 40 hertz maybe. A lot of designs really stop at 40 hertz. You'll still get down to 30, but it'll be down several dB. There was a company out of was it Australia? Anyway, they made these gargantuan speakers. But yeah, and that's how I started off. I made 6 cubic foot cabinets for my 12-inch woofer. And then I was playing down to 30 hertz with a sealed box. But the simple solution is just drill a hole in the box, put a 8-inch piece of pipe in there, and now you can play to 27 hertz, and for a lot of music, it sounds okay. But yeah, it's a trade-off. It's a commercial trade-off. Yeah.
You remember the original acoustic suspension speakers, like the AR1, that woofer, 12-inch woofer, okay, had very long excursion, but it had a very heavy voice grill. I think it was a 4-layer wound with number 20 wire. I mean, it was huge, with a huge, that had a very inefficient magnetic gap, but it did get down to 35 hertz in the box. That was the idea. Low efficiency, 82 dB or something like that. Okay, and a monstrously heavy thing. So you kind of wonder now, okay, what does it take to get that thing moving? That's another problem when we talk about response. But playing bowed bass, it sounded wonderful. So there is those amazing trade-offs, and because I grew up hearing big box speakers, the Bozaks, 4.5 cubic foot boxes for a 12-inch woofer, and I heard the concert.
Oh, you muted. You got muted.
Sorry, which had 4 12-inchers in a monstrous. It was looks like a wardrobe. It was 6 feet tall, 3 feet wide, and 2 feet deep monster, and we always lusted after this. And the bass in those was just glorious. I mean, talk about true concert hall bass. A pair of those,
Renee, which one was that again? Which speaker?
The Bozak Concert Grand. Go and Google it. I think there's a Bozak site back there. But yeah, they were wonderful. I mean, I heard a number of those systems back when I was a teenager. And we always wanted to have, oh God, we'd love to have one of those, 2 of those. Of course, in the mono days, you could get away with 1, but stereo, it was 2. But, then you need a fairly decent sized room to put them in. I mean,
oh, yeah.
You think the Maggies are big. I mean, a pair of Bozak Concert Grands. And it's like, anyway, but that's what it took to get good low frequencies, in a sealed box. Just a big box, a really big box. So that was, those were the days.
Siddhartha, one other thing about the sealed speakers versus ported is that just a sealed box is usually said to roll off at 12 dB per octave, below the box and driver resonance combination. And I think it'd be the FB.
Correct. Yeah.
And then just to get really unprecise here, say about the same size driver, about the same size box, ported, there could be a lot of different variations there in terms of all the driver characteristics and everything. But then that ported, instead of rolling off starting at 50 Hertz, it might be tuned to 30 Hertz, and maybe it really starts rolling off another 10 Hertz lower, or 15 Hertz lower, at 40 Hertz or 35 Hertz, it starts rolling off. So you look at the spec and you go, oh wow, the F3 is way lower. But at some point, those two curves, if you plotted them on top of each other, they intersect. And when you get down into the 20s, especially if you go past the lower cutoff of the ported box, you're actually getting lower tones out of the sealed box than you are out of the ported one, which may not give you this impression of having quite as much bass. But the lower tones are there. I've got a set of really beat up old, I don't know if anyone remembers these things, that I think they were German made by Sonic, and the model was David, so by Sonic David, and they had like 3.5-inch or 4-inch woofer in them, and the enclosures were smaller than the Radio Shack Minimus speakers, very small enclosure. Those, you can hear some content, it's way down, but you can hear some content like at 30 Hertz, and it's clean sounding. And no little tiny ported speaker is going to sound anything like that. You'll hear some bass like at 80 Hertz, maybe some at 70 Hertz or something, and after that, there just really isn't anything there. But in a sealed speaker, it goes off smoothly too. So that's the other benefit of the sealed speakers. You don't get quite as much just showroom impact out of them. But if you really listen to it, there's like lower content there, even in a fairly small speaker. So it's
the other beauty of the ported system is, so you could take one of those 10-inch woofers that Howard has, add a port to it, and it would produce probably a little bit more low bass than the twin sealed 10-inch woofers. So that's very commercially appealing. So because the port acts like a second speaker effectively.
Well, especially for theater, where you want crashes to shake the room. If that's what you're looking for, then a ported would be a lot better than a sealed, because it's much louder, and an airplane crash, you don't really care how tight
yeah, right. Can't walk away either way.
Car stereos, the ported boxes, it's like, okay, you only have room for so many woofers, but you want to destroy your hearing and rattle your rear view mirror. So but
another option that's really close to ported would be a passive radiator. Very similar response. Again, one of the trade-offs with that is the cost of having the extra passive radiator. But I probably had an example I brought to the club meeting here a while back.
Oh yeah.
It's got a 5-inch passive on the back and a 3-inch full range on the front. Otherwise, the box is sealed.
It was great. When we first played them, we thought, do we still have Renan speakers hooked up?
Yeah, they got a pretty wide full range to them. The 3-inch runs from about 80 or 90 Hertz all the way up to 20K. And you add that 5-inch passive on the back, and it's down 65 or 70 Hertz. Very small, compact box in the end. It's
Dana?
Yes. Hey, John.
Just one little quick thing. In Howard's description, he mentioned seal boxes rolling off at 12 dB per octave. but he never mentioned the roll off on a ported box at 24 dB, which is crucial to why they cross over at some point down low, probably.
Mhm.
Because I don't remember him saying that it was the 24 dB roll off that, you know, that you're getting
Right.
with its own issues of a group delay and other things
Sure.
against that 12 dB roll off,
Right.
but that starts at a higher frequency. That's all I just want to throw that in.
Yeah, and there's also 6th order alignments for ports, and I'm assuming that then means it's whatever.
It might
6
even
times-
roll off faster.
Oh,
Yeah, I'm not.
That would,
I'm not.
right,
I
the
think
the
there's-
6th order alignment they used an active 2nd order high pass as well ahead of the amplifier. So that's how you get your 6th order. And
Okay.
yeah, the advantage, I guess, is, well, there is an advantage to it. One of the problems with a ported speaker to begin with is that below the port resonance, okay, the speakers are totally decoupled from the box. So it's basically in free air. And now you can have a problem with over excursion in the cone. Yeah, so the 2nd order, high pass in front of the amplifier starts to roll off that other bass. Okay, the bass going to the amplifier, so that kind of saves the speaker. I'm not sure otherwise why you would do it, but of course, not a bad idea. I mean,
Yeah.
yeah. In fact, you might want to go to 8th order, but I hate to talk about, like John says, group delay. I mean, all of this stuff adds more delay to the low frequencies relative to the rest of the system. So anyway, also one other note too about what Dave's talking about, the little passive radiator. The advantages to passive radiators, I think, primarily is that they save box space. You don't have to take up a lot of space with a tuned port, which in a mini speaker is really critical. So the passive radiator allows you to have the full box volume and still get the effect of a tuned resonator.
I think it was Aaron Gilbert used to be a member of the other club many years ago, and he built a subwoofer that I think it was a 12-inch sub, and the box was probably 3 or 4 cubic feet. And he ported the box, and he needed a minimum diameter of 4 or 5 inches or something. And the length of the tube was too big to fit in the box. He couldn't even fold it up inside of there. So he mounted it like a smokestack. And it was flush on the inside of the box and ran outside the box. He accomplished the same thing, but it just kind of looked goofy, but it worked. And he saved money by not having to go to an expensive, very large passive radiator.
Right.
Now, the beauty of that,
It worked.
I saw one of those on Craigslist. The guy was selling. Yeah, so he had the box and this big PVC pipe took out about a foot out the outside of his box.
Nice.
It functioned the same, but it just kind of looked unconventional. That's all.
Yeah, right, exactly.
If you make it part of the speaker stand, no one notices.
Right.
Yeah, right, exactly.
Yeah, down firing port.
Well, down firing port, isn't that what? Speaking of Siegfried, do you remember his little Pluto speaker, which was constructed out of pipes? Okay, and that's what it used, the down firing port.
Yeah.
The woofer mid-range was mounted horizontally in the top of the tube, and it fired down through the tube. Okay.
So I got to run away, but you guys keep going. I'll be back in a few minutes.
Oh, okay. See. All right. And also didn't
Dave, on your little speaker, could you have fit a port inside that box that would have done what your passive radiator did? I mean, not just taking up the box volume, but could you have actually fitted in there?
I don't recall. I think I would have had to make the box a little bit bigger than I did in order to accommodate a port. It didn't need a very large diameter for that 3-inch, but I think it was still kind of long, and I was concerned about number one, fitting it in the box, and number two, the diameter versus the overall length may have produced some pipe resonance problems. So
yeah,
general rule of thumb is keep your length to diameter in the ratio of somewhere between 2 and 4.
Oh,
2 to
okay.
4 times the diameter maximum length.
Can't use
Beyond
soda.
that- and I'm not sure how critical that would have been on this little project, but
Couldn't use a lot of soda straws.
yeah. Oh,
No. Anyway.
excuse me. Oh.
Gary Geshellen's Vanuatu speakers
Yeah.
use the passive radiator very effectively. That a combination of DSP.
Yeah.
He gets quite low bass out of a very small enclosure. So
Yeah, I have never asked him specifically, but I would imagine he puts in some EQ on the low end, similar to that Linkwitz transform that Dana
Exactly.
did on
Yeah,
yours.
if you use the Linkwitz transform plus the tuning, the port
Right.
tuning down very low, which you could do with the PR. Yeah, you could get some pretty well extended bass with a small driver.
Yeah.
I was going to mention another, speaking of early passive radiators, my understanding is that one of Nestorovic's speakers used another driver mounted on the back of the enclosure as a passive radiator. And what he did was he tuned that driver by putting a capacitance across the voice coil. Now, it was used an actual driver and tuned it to some lower frequency. Kind of interesting, right? How to make it. You got any spare drivers around, use them for passive radiators and tune them.
My understanding was it only came on at certain frequency band.
Yeah.
So,
Right.
One of Nestorovich's speakers was built by Speaker Lab years ago.
Right.
A couple of models where the bigger, larger woofer was kind of semi-active, had a capacitor and a parallel resistor in series with the woofer, so it could control how much power it got down low. But it would go more. It would go more passive.
Interesting.
I've got a pair of those.
yeah, what was the model number on that one?
Well, I have the smaller one. It was an S30. They also made an S50, a really big one. So the 30's got an 8-inch and a 10-inch. The 50 had a 10 and a 12. And some of the New York Audio Lab stuff that he put out, if that was the right name, the Nestorovich branded speakers use that system.
I've always felt that from what I've heard that the passive radiator, I've always liked the sound of it better. It's I mean, it may just be that a lot of the commercially ported speakers, they go to an extreme or something, but I can almost always tell when I hear the bass out of a ported speaker, or maybe that's overstating a little bit, but I have the experience of hearing ported speakers and kind of without having to turn around and look at them, know that that's what I'm listening to. And I wouldn't say so much for certain ones with passive radiators that is for the same thing. So even though technically they do the same job, I've kind of always leaned towards a passive radiator as being less obvious of a device, although I'm sure there's as much delay and everything, just like Dana was describing the lack of transient response in the first couple cycles of the cone. It's probably the same with the passive radiator, but I've always liked them.
Yeah, I wonder what it is, whether it's maybe that they're better damped than a column of air. So I think damping may be better, because, and that's what Mackie did in the little monitors, that pair that I have that I played around with. It has passive radiators on the back, and it sounds to me much better than any ported speaker that I've heard. I don't know why, just something about the PR. So.
Well, you can also, I mean, most ported speakers don't call for a lot of internal sound damping material like fiberglass on the walls kind of stuff. And I think a fair amount of mid-range can come out of ports, especially the larger ports.
Right.
You can get a lot of kind of honky mid-range stuff coming out of them. There was a pair of, somebody gave me a pair of Infinity 2-ways with an 8-inch woofer. And a ton of the mid-range was quite colored sounding, and a ton of the mid-range sound was coming out of the port. I plugged up the ports, really changed the sound of them, not just how much bass they were getting, but it really changed the presentation of the speaker. So they were, you know, just depending on what was coming out of that port as part of and it was a front port, as part of the sound of the speaker, so part of the mid-range presentation. So,
yeah, that gives me something to think about, because if you think about the fact the passive radiator only has can only have one resonance point. It can only resonate at the point that its suspension and mass is tuned to, whereas the port can actually have multiple resonances due to, you know, structurally, if you think about it, not only the length resonance, but side to side, wall to wall. So that's true, is that the ported speaker may have more additional junk coming out the port than a passive radiator will have. So I wonder, be interesting somehow to isolate them, you know, stick the speaker in a window, measure just the passive radiator stuff versus a port, versus excitation, to see what comes out. Because
well, I was
interesting. Yeah, but
I was reading on a forum, and they're taking clay putty and tuning their passive radiator. So by changing the mass, you could then tune it for your room.
Sure, you could tune it anyway, right?
Yeah.
Well, you could tune it.
A lot of the passive radiators that you can buy now, they have a little stud, a threaded stud on there, and you can add washers and a nut to hold it on.
Right.
Really?
You can add and subtract weight on it that way. The little combination I have did come with those, but I chose, it sounded best with no added weights. But you can add as much as 5 of those little washers on there.
Well, it seems to me there is an optimum tuning for the port, depending on how smooth you want that extended bass to be. I mean, the further you push the tuning down away from the fundamental resonance of the driver, you can extend the bandwidth, but then you end up with this like sway back between the, you know, frequency response between the two peaks of the, you know, the driver resonance and then the port resonance. So there's an optimum distance. You don't want to try to get too much low bass extension out of a given design.
Right.
So
that's the experience I had with that 4-way that Dana pictured with that one slide, where there was the 4-way with the light colored wood waveguide on top of that, and then those woofer systems below it. There are 2 separate cabinets on each side, and the upper one has an 8-inch woofer that Madison sells from SB Acoustics. And I don't know how they do their measuring when they publish a frequency graph, but it shows that low saddle. And then when I used a tuning that was recommended by Madison with a port, those are actually have ports in them, but I have the ports stuffed. There was a saddle like that. There was more output low down, but it markedly dropped off. I mean, you could really easily hear it by running I have a tone generator. I ran that through it, just listened to it, and it got really noticeably less loud, say in, I don't know, 50 hertz range. And then it was louder at 70, and it was louder below. And part of that's my room, but yeah, I think that was because it was tuned real low. I mean, they said the tuning was supposed to be, I think, I don't know, somewhere 30 to 35 hertz or something like that. But I ended up liking them sealed, better sealed, or no, the port, stuffed port, and then had a fairly smooth roll off from there. And I just thought it sounded a whole lot better too, just in terms of how clean it sounded.
Actually, if anybody's interested, I do have a little update on my little passive radiator project.
Yeah, go ahead.
If anybody's interested.
Yeah.
Yeah.
Okay. So let's see if I can get you see I've got a amplifier box in the middle.
Wow.
Anyway, that I'm listening to a little bit of Rycooter today.
Nice.
Anyway, got a little, the guy that I'm building this for is a contractor, building contractor. And he's, let's turn this stuff off. He's, he likes good quality music. He bought one of these little DeWalt units and it sounds pretty scratchy.
I've heard him.
So, yeah. So he asked me if I could make something portable for him. And I said, well, not quite that small. It's only about as big as one of these speaker boxes. And he said, I don't care as long as it's good quality sound and it's portable. And he wanted Bluetooth capability with it. So I found an amplifier board. It's Bluetooth capable, plus it's got an auxiliary in, and it has option for rechargeable batteries, which is a very good thing for him. So it's, anyway, let me turn it off and I'll, disconnect it here. So, okay. So this is the front panel of it has, it's actually a 2.1 amplifier. So it's got stereo plus a 0.1 for a subwoofer. So I built, there's a subwoofer tap on it as well as the left and right speakers up here. I just used a blank terminal plate cup for adding these lights on it. It came with a variety of lights. So you can, if you push this button, you can see two of those 4 lights are lit up. That means it's somewhere around, the batteries are charged about halfway. I can plug in my power supply in here and it'll play off the power supply while it's charging the batteries, which is kind of handy. And there's an auxiliary in here as well as the power in that I put over here. And I'll take the top off of it. And you can see down inside here. See a little bit there. There's the amplifier board with the heat sink up on the top. And then the batteries with the rechargeable batteries are on a separate charging board down below. So anyway, it's going to be, it sounds pretty nice and it's really going to be portable. So I've also got, I found some brackets that, so the speaker can hang on the side of the ends of that center box. And then I've got some spacers on here to keep it from flopping around. But these, I was looking for something fairly slim and compact for these little brackets. And I went to the hardware store up here and I found in the picture hanging section. So it's another bracket mating, or just identical to this, just upside down on the mating part. And it just slides over. So anyway, it's kind of a neat little deal. So that's about where I'm at with that. I've got I just finished the center box yesterday. I'm making it out of walnut and birch plywood. It hasn't been stained yet, but it should darken it up a little bit. It should be really pretty when it's done too. So I still have this matching speaker boxes to make, but the center unit box is all but done.
Very nice.
Ah, sweet.
Looks great.
Nice.
Are the amps Class D?
I believe it's a Class D, yes.
Mhm.
Yeah.
Dave, what are those batteries? Are they 3-volt lithiums or?
Yeah, it's
Mhm.
it's Yeah, that's a common number. What is that? The 180650 or something?
Mm.
So the 5 of them, the battery charging box holds 5.
Yep.
Which I think ends up around 18 or 19 volts or something.
Mm-hmm. Right. Okay. Yeah.
But the
3.6 lithiums. Yeah.
Yeah.
Right.
The
Mm-hmm.
I got all of those boards on the Parts Express, and the power supply for it is a 19 volt. So
Mm-hmm.
the amp board will operate anywhere from 12 to 24 volts. So I just had to find the right plug size and the power cable stuff came with it. It also came with a 12 volt adapter for the cigarette lighter in a vehicle. So you can charge it off that while you're driving from site to site. He'll have plenty of options. It also has a USB power, so it'll charge probably a little slower, but you can play it off of that, or there's a lot of different options.
Great.
Nice job.
Very
Yeah,
nice.
that's cool. I like those clips. Those are really cool.
Yeah, go into the picture hanging section and you might find those. They're only about 3/16 inch thick, so it's kind of a small little hat section. And a little tongue on each side. They're identical parts. You just flip one of them upside down and the holes match up, so you can just match drill through the 2 parts. Looks pretty slick.
So, John, tell us what you've been up to. We haven't seen you in a while. Yeah, okay, unmute yourself. No, need to unmute.
We still see the muted symbol.
Yeah.
It
There you
bounced
go.
back and forth on me.
Okay.
Nice.
So how
Switch
are you? How are you, and what have you been up to?
I've been fighting a bad back for the last 10 days. Can't do anything.
Wow.
Friend and I were out, I guess it was a week ago now. We were getting a whole bunch of sound absorbing panels from a contractor that had excess from a project. They put them into a big, I don't know, auditorium or a athletic hall or something. And they had this 1 inch thick in 4x8 sheets. It's a fibrous mat, all left over. So we got about $6,000 worth of it for $200.
Wow.
A 4x8 sheet was, I think, $180, he said. And we got like a pallet and a half of it. So I haven't done anything with it yet, but that's something to be done. I've been working on restoring some old Heathkit tube amps lately.
Oh.
They're EL84 mono amps, but my back has kind of paused that project. What have I done before that? Mostly I've been working on tube stuff lately. Commercial products and some build-it-yourself DIY stuff. I built one of John Broski's Aikido line stages a couple months ago with all 6 SN7s, and this sounds really nice.
Wow.
And I had a Dynaco SCA 35, an integrated, that I completely rebuilt with all new boards and so forth from a guy named Dave Gillespie. So he has a special power supply for it that supposedly reduces the distortion a lot. That was fun. And I got this big old pair of Radian coax drivers. Dave's got my 3rd one I bought so that I could, he said someday if he ever felt like it, he might take a look at it and see what he could do on a crossover. But I got the factory crossover, so I mounted them into this old box. They're a 15 inch with a coaxial horn through the middle. And even with the factory crossovers, they sound pretty good.
Yeah, the Radian drivers sound amazing.
They were very expensive drivers. They're about $750 a piece new, but 2 other friends and I, we each got pairs of them for $300 for the pair. So it was a good deal.
Wow.
And so I had some old classic, probably early 60s boxes that were about the right volume based on Win ISD and some measurements. And so I put them in there, and I've been having some fun listening to those with different tube amps mainly. I think they're about 98 dB sensitivity, so they do pretty well with most just any tube amp in my little room.
Cool.
You know, I guess that's about the size of it around here.
Excellent.
Yeah, that's been busy.
Well,
How about what's the weather report out at the ocean, Dana?
Well, I'm actually not there right now. I'm actually back at Everett.
Okay.
I was supposed to be there, but car issues got in the way. But it's clouding up. I think it's going to rain the next week. But it was, when I left, it was incredible. It was just beautiful. It's always nice when you leave. You know, it waits for the last day and it just turns sunny.
I know. I was looking. It was 40 degrees and rain in here, and it was 60 degrees and sunny out there a couple of weeks ago. And I was like, "Oh, I should go," and I couldn't get out there. Oh man, you been playing with your anything audio lately?
Well, yeah, I have a tube DAC and a little Deckware 2-watt tube amplifier, and so I've been tube rolling.
Nice. There you go. So
I found that what I really like are the tubes from the 60s. I guess they're called D-getters. I mean, I'm learning more about tubes than I had any idea, but the shape, different years they change the shape so you can kind of tell what year they are. And so these old tubes are just magical. They're not cheap, and you know, I'm kind of worried that I'm really going to like them, and then, you know, nobody's making 1960s tubes anymore.
Yeah,
that's really a shame. You know, that's the problem because they really are good. They made some good tubes back then.
So I bought some 73. I bought a whole bunch of 7308s, which were supposed to be the holy grail of tubes.
Oh yeah.
And they have a higher gain. They're louder, but I don't think they sound as good. I'm sort of, you know, doing that. But just other than that, just playing with it. I put a tube adapter in my DAC. It was supposed to take 5670s. And you can get an adapter and put in 6922s. And the 6922s sound, I think, a lot better than the other ones. So yeah, I've been playing with adapters and it really does change the sound. I thought everybody was crazy. You know, oh yeah, I hear this tube and it has this, and they're really not. It really does. You really can fine tune stuff with tubes.
Yeah. Wow. That's fun.
But my other question to you is, so I have these big corner horns, but to DSPM, I don't know what the woofer is. Can you do a measurement to figure out what kind of, you know, what kind of roll off or things like that you would want? Is that how you would do it? Because they're sealed inside the
right
big thing, and to actually see what they are.
Yeah, you could do a measurement, you know, an impedance measurement sweep would tell you kind of the resonance of them in the box, and you could use that to go from there, because that'll tell you the Q and the frequency if you wanted to do a, you know, similar, depending on what you're trying to accomplish, but that would tell you what they're doing. And of course, then the horn fits into the, you know, ultimately a microphone in front of them would, you know, you might like to try out, you know, a room EQ kind of a thing, or whether you actually want to get in there and do a digital crossover. You know, I mean, there's different, depending on how much you want to do. I mean, you could start off with a room EQ because that's easy to do. You just need a microphone, and then you can load the equalization into like a player, like oh, my brain is the PC player. JRiver will run a room EQ filter right inside of it, for instance. So you wouldn't need anything. You really wouldn't need any special hardware to do that.
Well, I was thinking about changing the driver, going from, it has a 1-inch driver and going to a 2-inch driver. This guy makes these CNC horns that you just glue them together. So they're 3/4 inch MDF, and he's cut them so that you just glue them all together and it makes this horn.
Wow.
And so that's, and then you get, there's some really high-end drivers that you could put on that. It's supposed to sound really good, but I'm worried that my current crossovers probably won't be the.
I see. Yeah.
So I
yeah.
thought maybe DSP would be the better way to go.
That would certainly be easy. Yeah. If you especially if you had, a lot of people have more than one amplifier sitting around. So who cares? You need a second amplifier, right? So,
yeah.
That would. Well, and then once you, so a mini DSP, and you can just get in there and adjust it and measure it and listen to it and adjust it, until you're happy. So
And at that point, yeah, okay.
Yeah. And then I could even come out there and do it with you.
My
Oh, I would
experience
like
when
that.
you start making all those measurements is you can never be happy.
You can't.
Right.
Don't tell them the truth.
The truth will set you free, right?
Yeah. So Renan looks like he's set up to show us.
Yeah, I
his
just
amplifiers.
I can't get down that low, but anyway, here's what you're looking at here are two monoblocks, Class D, made by Orchard Audio. They're about the size of the palm of your hand, basically. 150 watts per channel, fully balanced, using gallium nitride transistors, made in the USA by a company called Orchard Audio. They're out of New Jersey. Had extremely good reviews about it that I read. Technically measured really well on the Audio Science review site. And so I thought I would purchase them. They're hard to come by because there's greater demand than there is supply. But anyway, finally they arrived yesterday. I plugged them into the system and they sound amazing. Every bit as good as what reviewers around the world have been saying about these little monoblocks. Price of them, $1,200 for the pair. They come in DIY form too, where they supply you with the board and the chassis and so on, and you just assemble it. That's $800 for the pair. But I just thought I wanted to see how good Class D could be, and these are supposed to be sort of the current state of the art, sort of compares better than Bruno Puzzi's designs. And so I thought, let's get this and see what they sound like. And the next time around, we have our DIY meeting here at the house. We can listen to these, really worthwhile, and a pretty reasonable price. And they're quite a bit in demand. They're hard to get hold of. You can go to his website, Orchard Audio, and the name of the monoblocks are Stock Crimson. He named them after apples. And you can read the reviews and the technical details about these amps and how they were designed, the way they were. Amazing, just amazing. Very clean sound, very sweet. I mean, nothing harsh about them compared to the rest. The Jeff Rollins, I would say, did just about as good as the Jeff Roland, maybe better. So, I mean, to my ears, they sound very natural.
That's saying a lot, Renan. You've gone through a number of amps and
I've gone through a number of amps in the past, but I just took a chance on these just to see what they would be like. Turns out they're worth it, and they're fully balanced as well. What else can I tell you about them? The details about how they were designed are written up everywhere online. You can go look at the specs on it as well. I think Amir has measured it. Distortion extremely low. Yeah, run totally cool. You can run them. You can leave them on, and they consume 6 watts when idling. So, yeah, it's kind of amazing the state of where things are, and how good things are sounding now.
Mm.
Yeah, I was surprised, very surprised. Anyway, I just thought I'd mention that before it got too late.
Yeah, they look great.
Yeah,
I like the amplifier stand as well. You know, the
yeah, I just pushed them on top of the Jeff roller. They just sit there.
very
now.
beautiful.
Yeah.
Well, you've got them on a good
I
solid
also like
platform.
the idea that you can build them yourself, for lesser price. I mean, not hugely lesser price, but you can build them yourself. The boards are available. Anyway,
Oh, neat.
yeah. Yeah, and that's about all I have from this end.
Wow.
Looking forward to hearing them. We're going to apparently the next Pacific Northwest Audio Society meeting. We're going to have a guy who's been developing gallium nitride power amplifier too. Of course, his are going to cost $25,000, but there's no need for that. I mean, it's like. Yeah, I think Orchard. I read Orchard early on. Originally, you could get the boards for $500 for the pair, but I didn't jump on it, unfortunately. But yeah, gallium nitride's definitely the way to go for Class D. It is a little bit trickier to to implement than other designs. They're quite fussy, but they do have tremendous benefits in the in Class D operation. I think the big problem right now is that gallium nitride has become so popular throughout the power industry that there's great shortages of parts. They just can't make them fast enough. They're converting a lot of stuff. Some of the big industries like telecom, because you can make 98% efficient, power supplies with these things. So there's obviously a huge demand for systems that require, like servers that require large amounts of DC power at different levels. So yeah, pretty interesting. Yeah. Great stuff. I think the last gallium nitride part I saw announced was a 60 volt, 417 amp device. It's about a millimeter square. It's like, you can't believe it. I think it's a little bigger than that, but it's a few millimeters. It's incredibly small. I couldn't believe it, and it's because the on resistance of the device is 2 milliohms. So you turn it on hard, and there's practically no dissipation.
Wow,
pretty scary.
Wow.
So are those the chip amplifiers themselves that are that technology? The amplifier core itself, the same as like other chips, like a LM3886.
No,
chip
I have not. I have not seen anyone do an integrated gallium nitride design. Okay. It's just that the gallium nitride lends itself very well to the power devices, but I'm not sure there's an economy to the rest, doing it for the rest of the circuitry. And then the question is, I don't know what the requirements are in, when you're integrating different components on one substrate. There's certain requirements, and I'm not sure how well the gallium nitride lends itself to that. So there's another, it's right now, they're just discrete power devices. And as far as I know, the rest of the circuitry is just standard silicon technology. TI makes a little driver part to drive these things, fast enough to do efficient switching. It's a separate part, and then you'd have other op amps and so on in the front end to whatever to handle the analog part. Of course, you could build a digital, all digital amplifier the way Technics did. We heard the Technics a couple of years back. That was a gallium nitride power amplifier, which they want $15,000 for. But that's it sounded really good to me at the time, and of course it had some nice things. In fact, apparently they've just come out with the second version, which is a fully integrated amplifier with gallium nitride output devices, but it's still like $9,000. I mean, it's, come on, you know. So it's a tour de force, but
Yeah.
it has the loudspeaker, you know, the interface that looks at the loudspeaker and corrects, you know, for loudspeaker damping and a bunch of other things. So it's nice, but no, the Orchard are really good. I watched the company start up, and you know, I'm glad that they're doing well. Like most people trying to build anything today, I hope they can get parts.
Here's what the amplifier board looks like.
Yeah, right. Cute.
Yeah,
Yeah.
and really.
Yep, there it is. Yeah, right. It's
That's-
just practically nothing
That's
there.
150 watts per channel.
I know.
Fully
Right.
balanced design on that.
Yep. Mhm.
It's just amazing.
Right. Very nice. Yep.
Yeah. See, I could have dropped a
Yep.
couple of those boards into Gary's amplifier box, and we could have kept going.
Yeah.
Oh man. Yeah. Oh yeah. Talking about parts. So I finally got a replacement JBL tweeter from Morgan Sound in Linwood, and I ordered it a year and a half ago. And they called me up and said, "Hey, you remember us?" So the supply chain is barely working, but it's working.
It's amazing. Yeah. Right.
Yeah.
Terrible.
Yeah.
I've got a question to throw out there, see if anyone has any great ideas. With my surfboard open baffles, at home, I'm mostly going to play them as probably bi-amp and then another amp for a subwoofer, which will be a single dual voice coil, basically open baffle. Maybe it'll have a bunch of stuffing stuffed in the back of it, but a not very big 15-inch and a not very big cabinet. But so I haven't done an impedance sweep on the prototype crossover or impedance measurement, you know, and so I don't really know what it is, but I'm guessing that it's going to end up being overall kind of like maybe hitting 4 ohms at a couple places and generally being maybe a 5 or a 6 ohm speakers or something like that, not bi-amped. And so I'm thinking of ultimately a way to run it all passive if I want to. And so then the woofer has the dual voice coil subwoofer has 2 8-ohm coils, and I can't run them can't run it in series, or else the inductance from the woofers will just, you know, roll off the upper end of everything. So I have to run it in parallel, but I'm going to end up, you know, down at 3 ohms or something like that if I do that. Is there any better way than just putting power resistors in line to bring, you know, 4 ohms or 5 ohms or so of power resistor in line with it all to bring it up to make an easy load on amplifiers? Or is there any other way to do that? There's no impedance matching transformers for 100 watts, right?
Well, so
There are, but it's tough going down to low frequencies. Why don't you just get a powerful amplifier? You just need a bigger amplifier.
And just use the power resistors?
No, don't use a resistor. Just drive them. You really want to drive them directly.
Well, you put the coil in there, you'll have resistance from the crossover coil's going to be
the crossover coil. Yeah, you could always use a coil wound with like number 20 wire or something.
Yeah.
20 millihenries with, you know, with number 20 wire will bring you a few ohms.
Yeah. Right.
Howard?
Right. Yeah.
Are you familiar with a company called Anti-Cables? I think Renan has some of their wires.
Yeah, I do.
They make auto transformers to hang on the output of an amp and bring a low impedance speaker up to a higher reflected impedance on big toroidal cores.
Does the auto transformer have like multiple taps?
Yeah. It's a single winding, but it's tapped in different places. So
It's an auto,
But-
yeah. Can you send us a link to the company? Who is this?
This is John.
No, who's makes these transformers?
Anti-cables.
Yeah,
It's
anti,
those-
Anti-cable.
right.
Renan has some
Mhm.
of their speaker cables.
Yeah.
Okay,
All right, and we'll look at anti-cable. Yeah, right.
Right.
okay. I mean, that's basically the kind of product that I was thinking. I mean, the main thing I'm thinking is being able to, drag it over to Renan's house or bring it to the speaker contest or something like that, where you don't want, you're not hauling your own several amplifiers.
Sure.
But at home, it
Yep.
won't be a problem because I'll, because it won't be that hard.
Right.
It sounds,
Mhm.
I'm playing one prototype right now. I mean, I actually finished the speakers, but the crossovers are prototype. And so I'm just using a stereo amp that has a mono button on it. And I'm running the two 12-inch woofers off of one channel and then the upper three-way off the other, and then just twisting the balance control if I want to adjust the sensitivity. Here we are.
Oh dear. Yeah.
They're beautiful.
Yeah.
Oh, yeah.
Whoops. All right.
40.
Oh, yeah, a
Wow.
little expensive, huh?
That's expensive.
$640, you can get a transformer, no question.
Right.
Oh,
We
That
can
would
find
do
our
the-
own.
Yeah, that would do the job. Wow.
Buy it now.
There you go. Anti-cables. There you go. Autoformers.
Yeah. Okay, good. Yeah, right. All
There
right,
you go.
interesting.
Anti-savings.
Yeah, so Howard, there's your solution, Howard. You have to find out those who knows how big they are, whether they can handle any low frequencies or not. We'll have to see.
Wow. Yeah.
or if the Jeff Rowland can play 3 ohms.
Yeah.
Yeah. Oh yeah, no question.
the Rowland can play into
Rowland can
1 ohm.
handle. Rowland can handle 2 ohms. I think
Okay.
the Orchard Audios can handle the 3 ohms too. I don't think there's a
Sure.
problem with those guys.
Oh yeah.
Then that'll probably work.
The
Yeah, the
ordinance
Rollins have like what?
says 2 ohms is okay.
And I really think if you make a passive crossover with a roll off on the, a low pass for the subwoofer will involve an inductor, and that's going to have some significant DC resistance.
It
If
sure
you
is.
cross over, especially fairly low. Even if you
Right.
go not even a 20 gauge, but even if you go down to 18 or 16 gauge, it'll still have
It'll still have, yeah.
fairly significant DC resistance. It'll probably bring it up above that 4 ohms anyway.
Yeah, it definitely will. Yeah.
Yeah.
You probably want to use one of the inductors wound on the laminated, iron core just to get the DCR down.
Yeah.
Because otherwise you're going to spoil your damping, you're going to raise the Q of the driver quite a bit. But anyway,
Which
Howard will
might
play.
be good for the open baffle. That could be good for open
That's
baffle.
true.
'cause
Yes, for open baffle that would be fine. Yeah, because what is the Q of the drivers?
I think it's probably actually fairly low. This
Yeah, then you want the
this-
R. Yeah.
it's a vintage JL Audio dual voice coil 15, really heavy cone, big magnet, and
Yeah.
a resonance frequency below 20 hertz. So I think it probably was a
Open
pretty
baffle,
low
huh?
Q,
Whoa.
probably pretty low Q driver to begin with.
Right.
So maybe it can stand quite a bit of
Yeah.
resistance. Yeah.
Yeah. Okay. Yeah. Probably will like it. In fact, right. Sounds good. Sounds like the way to go.
The open baffles without that sub actually sound pretty nice. They're pretty strong to 45, 50 hertz, just the way they are. So I mean, they're real decent to listen to just the way they are. But the deep pulsing bass it's a little thin there, as far as stuff that really hits hard.
Well, yeah, just as an example, Terry Olson's 18-inch
Yeah.
open baffles that I put in that, I crossed them over at about 170 hertz to
Mhm.
the other coax above it.
Yeah.
And the low pass used a 9 millihenry coil. I think it was 18 gauge, but it might have been 16. The DC resistance on that, I just looked up, it was 1.8 ohms. So it added quite a bit.
Mhm.
But like
Right.
Renee said, if you use one of those steel laminate core, your DC resistance goes well below 1 ohm, maybe even less than half an ohm on some of them.
Right.
With the problem with those that when you read about it is people say, well, the iron core type of ferrous core inductors can saturate and then cause distortion. But I wonder if it's really, I mean, we're much less sensitive to distortion below 100 hertz. I wonder if it's really an issue down low. You know, I know I used iron core on my 18-inch too, and it sounded pretty good.
Well, and depending on the size of the core, the saturation may not occur for several hundred watts.
That's right. Yeah.
Right.
Right.
And
you got to
only-
remember there's a huge air gap in those, you know. I mean, the iron is only doing a little bit. It's just concentrating field there, but it's not like a transformer, a closed circuit transformer where the laminations can saturate. It'd be like Dana says, probably several hundred watts before those things would saturate. Yeah. We can
Right,
test
and
it. We could test it. We
eight-
could check it out. We
Okay.
just wire them across 60 hertz and put them on the variac and find out, you know, where they saturate. It's easy,
Sure.
you know.
Yeah.
Yeah, if it takes 120 volts at 60 hertz, then it'll take 40 volts the coil at 20 hertz, and to get 40 volts across a coil means you're driving it with a couple of kilowatt amplifiers.
Yeah.
Let me tell you, I don't think it's a problem, but I actually have some of those iron things. I think I'll check one out and see what it will take, because they're designed for high power speakers.
Well, I have some huge air core coils you can have anytime you want them, Howard. I got,
We'll give them a try, Dana.
yeah, I think they're 12, maybe they're 12 millihenry. I don't know, they're big. They're
big.
about so big around.
Yeah, right. Right. I think I gave Howard a couple of big ones too. It's like, they're.
Oh, well, remember those big iron core ones that look like big spools of wire?
I think those were actually aluminum cores. I think it's just they wound it on aluminum rod just to have something to wind it on.
Okay, just get something for an armature.
But they are big. Yeah, the alternate would be to buy a couple of pounds of, you know, like 14 gauge enameled copper wire on a spool, and hopefully they'll bring out both ends so you can see a pre-made inductor. It's very large.
Yeah.
Right.
Right.
Yeah.
Oh man.
Anyway. The joys of passive crossovers.
One other thing I can say about the, I think I got the frequency response on the surfboard style in pretty good. And it's interesting, just listening, running a sweep with a tone generator is, I don't hear as much kind of, you know, from one frequency to another kind of woo, kind of level variations. And I'm guessing it must be mostly because it's not in a box, and not making resonances in the box, because it just sounds smoother when you just listen and run a sweep, slowly run a sweep. That's an interesting characteristic of the open baffle. I hadn't really noticed that before in anything I'd done. But compared to the box speakers, there just seems to be not so much reactivity, or whatever variation in the frequency.
Okay, listen, guys, I have to go. I've got some errands to run before 3 o'clock. So
Okay.
Yeah.
We'll talk to you later. I'll see you next week meeting.
Renee.
Yep. Take care.
Take care.
Take care.
Yeah. Well, I'll share my recent purchases just for grins. So record by Pamplemousse. Name of the record is impossible to pronounce is the name of it. So I don't know if you're familiar with Pamplemousse, but it's a kind of a high-end cover band put together by the guy who the founder of Patreon, the thing that helps musicians and whatever artists collect funds. And so it's just kind of fun. They did a limited pressing. There's only whatever, they're only making 1,400 of these. So I thought, well, I'll buy one. It's all French music, but kind of whimsical. I happened to hear, you can hear all this stuff on YouTube for free, but there's a really nice song called the Fast French Song. If you look up Pamplemousse on YouTube and listen to the Fast French Song, and it's got subtitles. So you can read what she's singing, and it's pretty hilarious. But anyway, last year I bought my mother a record changer, and so I thought, well, I'd get her some ammunition for it. But my other purchase was I hadn't yet to join the wireless headphone, set. But so these little guys are I guess kind of like the Apple, but except these are about $45 instead of 200 or whatever. They're Sound Peats, and they have a little. I can't handle the Apple ones. With the all hard plastic. These have a little rubber interchangeable ends, so they're more comfortable. But yeah, so they'll hook up to your phone, Bluetooth, whatever. And so I bought those this week, and they sound really pretty nice. They charge when you put them in the case. That's what they're doing now.
Wow.
So it's interesting. You plug the case into your USB, and it charges an internal battery. And then when you store them in there, it's charging them in the little case. So it's kind of cute.
What's the name of the manufacturer?
And so it's called Sound Peats.
Peats.
So, yeah, SOUND PEATS, and I got them on Amazon, or where your favorite mail order retailer will have them.
Great.
Hey Dana, can you last time's DIY you had talked about a what is it, like a electrical thing that plugs into the, like it allowed some relatives, I forget now, to have their refrigerator run. Can you send me the link to that on text?
Oh, sure. Yeah, the EcoFlow.
EcoFlow, that's right. It's this thing that when the power goes off, you use, right?
Yes. Yep. I got it sitting. I have it sitting right at my feet. So yeah, it's
it charges the rest of the time. It charges on the main electrical power supply, right? The main.
Yes. Yeah, exactly. Yeah, they have all sorts of different sizes. Depending on how much power you want, you can get. I think the one I have is a 3 kilowatt inverter and a couple kilowatt hours of power, 2 kilowatt hours of battery. So you can run just anything in the house with it.
What was the? I guess are those things pretty expensive, or are they?
Depending on the size, they're going to be. I can't remember what this one was. $700. Something, different. As you get the larger ones or smaller, the price course scales. And so you kind of figure out what do you want to run? So I thought, well, we wanted to run a furnace and a refrigerator, probably for a day or two. So that's kind of how I picked this size.
And it just, all your devices just plug into this, the furnace and you don't have to kind of connect it to the electrical, the main circuit board.
No, so you can just run extension cords to a couple things with this thing. And the advantage, there are several of these. The advantage to this one was it fully recharged in 2 hours.
Wow.
So the beauty of it was, if you're sitting there running a generator, if your power's out for several days and you don't have a lot of gas, you could run the generator for 2 hours. This would be fully charged, and then you could go for a whole day after that running things with the generator off. Or you want to go to bed and you still want to have, your refrigerator running and your furnace. Well, then you can do that. So that's
your
and it's quiet.
Refrigerator is connected instead of the main. You unplug it from the wall and just plug it into this.
Right. That's the easiest thing to do. Yeah, I plug my refrigerator into an extension cord, And then so I have that extension cord and the refrigerator plug just on the side of it, so I can pull it out easily. You know, 'cause it's a pain to roll your refrigerator out, right?
Yeah.
And so if you
Yeah.
when you get it out to clean it someday, if you plug it into a short, you know, you only need a 6-foot extension cord maybe, and plug it into that. That way, it's kind of, you make it available. Then you could plug it in, unplug it from the extension cord, and have the cord out by the front of it. But yeah, anyway.
So Dana, my question is, can you use this for like your audio and your computer actually? Would it be a
Sure.
bad thing for your audio? Would it make the sound really bad if you plugged it in?
Oh no, it should be beautiful. It makes a sine wave. Yeah, this is a sine wave inverter, so it makes a very pure sine wave.
So it won't distort. I mean, it'll just be fine to plug the audio into this.
Oh yeah, should just be great. Yeah.
And even computers, hard drives, would be quite happy with this.
Everything should be great. Yeah. Yeah. If the lower cost ones, they call it a modified sine wave, which is like a couple of square waves, right? And those make things buzz, make motors buzz, make those are the lower cost versions. So you can buy this kind of thing at a lower price, but it would have those lower quality modified sine wave output. Basically square waves. Most of this, yeah.
So then the question is, you know, I've seen some things on eBay made like the same design. What made you choose this one versus, you know, like these other ones that you can get on eBay or other manufacturers? What was the thing for you that made you choose this particular name or size?
A YouTube channel recommended it, and the guy had reviewed it. He really took it apart and showed all the internals, measured it, and the kicker was there's, you know, he reviewed 4 or 5 of these, and the other ones charged very slowly. So this one, because of its quick charge time and its high quality, I'd say the only, you know, disadvantage to this one, it's not super efficient. You know, so if you go buy a dedicated sine wave inverter, like I did for my RV, I bought one that was 95% efficient. Right. So very, very efficient. This one I think is more like 80% efficient or something. But for what the use case, I think it's fine. You know, it's very portable. It's got handles on it. I can pick it up. I can move it. I can take it, like I said, to my in-laws if power goes out or whoever needs it. Plug it in and not have a care.
And the one just curious, the one you got for your RV, what name is that? Is it the same company or different?
Well, so that was just the inverter. It didn't have batteries. It didn't have a charger. So that was an Ames. This is the brand.
AIMS?
Yep. AIMS, Ames. And but so then that you have to then go find your own battery, find your own charger, you know, kind of assemble something. You know,
so this is called EcoSource, this one?
EcoFlow.
So yeah, if you can just send me the link on text or email.
Yeah, I'll email it to you, no problem.
Great. Yeah, that I couldn't see it properly last time. I couldn't for some reason I couldn't discern what it was. And so
I think I got it through Amazon. You can EcoFlow and search just ECO Flow on Amazon, and that's how I found it. You can have it.
And yours is a 3 kVA.
I think so. Yeah. Yeah.
Well, I like the idea of actually plugging the audio into it, because you know I've sort of been concerned about, like, when you have these you know, like you'll have the power go off and then come back on,
right,
which is really bad for devices,
right?
If something like this was able to just come on in some milliseconds, then you wouldn't have that, the device, the power would stay on actually.
Yeah, I have my audio stuff plugged into an uninterruptible power supply I bought at Costco, the sine wave ones. They won't run it for very long because they have a
Yeah.
small battery, right? They'll
Yeah.
only run it for maybe 10 or 15 minutes.
But you can at least switch off, you know.
Yeah, exactly. Yeah. It
Mhm.
because with the power flickers, you get the spikes, and that's can break things.
Yeah,
And
exactly.
so
Yeah.
yeah, for a couple $100, I bought those at Costco, and the sine wave ones, and they were great. Yeah, they have two of those 12-volt batteries in them, maybe 9-amp 12-volt batteries, and so they'll run a computer for half hour or something, or they'll run but it might run your audio equipment quite a bit longer. But I have those scattered around the house, so if you're playing the Xbox or you're listening to music or something. Critical stuff that needs to work.
Exactly. Yeah, the important stuff.
Yeah.
So does an EcoFlow? So my house at the coast has a panel to plug the generator in because the power in Shores is constantly going out.
Oh yeah.
So I didn't think about just buying batteries and an inverter and then having them charge because the generators are a pain.
Right. Yeah. Depending on how long the power's out. Yeah. This thing will run, depending on which size you get, you just size it so you can go for 12 hours or 24 hours for a couple things that are critical. A lamp's only 5 watts. You can run an LED house lamp, for a long, long time.
Would be nice to keep the fridge going and be able to turn the heat on because of course it happens when the weather's the worst. So
of course, yeah.
But if you could charge it, so I have a generator, but if you could charge, you could charge this off your generator for 2 hours and then run.
Yeah.
That's a great idea.
So I bought the Harbor Freight 3500 generator to go with it. And so yeah, it puts out enough power to fully, I think I started off with the Harbor Freight 2000, but I realized they rate their generators. The 2000 is the peak. It's not the continuous. So I realized, it's really only 1600, and that's about where this thing is. So anyway, trying to charge this in 2 hours with that one was going to max it out. And I thought, well, I wouldn't be able to do anything else while I'm charging it.
Right.
So I went back and exchanged it and got the 3500.
That's gas based?
Yeah, go ahead.
That's gas based?
Yeah, so that's gasoline. If you want to be really plush, you get the one, you get the natural gas fired generator that automatically starts, but then you're into $4,000 and whatever. Yeah.
Well, plus installation.
Right. Yeah.
Plus the switching panel and all that stuff.
And then you can run your whole house, and then that's beautiful. That's a really nice solution. But it just depends on how often your power goes out, and
Does your EcoFlow unit, does it only charge off of 120 volt AC?
So it will do 120 volts. It has inputs for solar panels. So it also has built in the maximum power point tracking charger built into it. So I can hook up couple 100 watts of solar panels to it if I want to, or you can hook it to, I think it'll just charge off at 12 volt. You can hook it to your car and idle it, and it'll charge off of that.
I was picturing RV kind of usage.
Yeah,
if you could have that be your power unit, integrated power unit.
Yeah, so it's really flexible. That was kind of the beauty of it. It really just does it's a Swiss Army knife of power.
Yeah.
So yeah, neat. Well, maybe we were
very nice. Thank you.
I guess we should probably wrap it up unless anybody else wants to kick in. Nope. Very good. Well, thanks for all coming out. I enjoyed it thoroughly. That was wonderful.
Yep.
Thanks, you guys.
All right.
Thank you for sharing.
Right. Great rest
Thank
of your day.
Dana.
Thank you, Dana.
Thank you.
I'll see you, John.
Everybody else.
See you guys.
Siddhartha, give me a call, Siddhartha.
Yeah, I will right now. Yeah.